Good evening, dear all. Very good evening. So, welcome to the Gradeup, dear students. Adnan Bhai, good evening, dear. The India's largest e-learning platform, the Gradeup, welcomes you all on the sessions for the Production Engineering Part 2 for the NLC GET 2020. Come on, dear students, join the session. Today will be the second day from my side as far as this production engineering is concerned. Good evening, Adnan, Avilash, Ashutosh. Come on, join the session, dear students. And in the today's session, dear students, I will be covering about the material science, the casting technology and metal forming, as well as I try to include it here, the metrology also. Hi Arvind Singh. Okay, so come on, very fast, join this session so that we can start. Good evening, Bhupesh. Good evening, dear. I welcome all of you on this Gradeup. Sai Pratap, welcome, dear. Good evening, all of you. Good evening. चलो join करो, like करो, so that we can start. So dear students, this is about me. I am Onkar. I have mentored more than 10,000 students for the GATE and ESE. Okay, and having more than 10 years of experience. And my area of expertise and the interests are production and industrial engineering and fluid mechanics. Nitish, Kuldeep, Anil, good evening. Raju Venkat, very good evening, dear. So in the today's session, our aim is to cover up the casting, metrology, metal forming along with the material science. So are you ready, guys? Are you ready? Are you ready and are you with me? So I need your response for the every question. So of course this is the fast track revision we are having. This is the marathon year. So just most important questions as a practice for NLC 2020. So let us start. Shall I start? Okay, fine. Let's go. Tell me the answer for this. The Gibbs phase rule is given by. So very simple question from these phase diagrams. Tell me the Gibbs phase rule is given by. See, the symbols have their usual meaning. In the symbols also they have given the meaning. F is the degree of freedom, C is the number of components, and P is the number of phases. Yo Saurabh, tell me dear, what is the answer? Say yes, come on. Yes, join this session. It will be very interesting, dear. We will enjoy and learn. Okay, fun and learn together. Very nice. D Amir, very good, dear. Shubham, very good. So I hope all of you have answered till now. Everybody answered correctly. Tejasri, very good. Anurag, come on, give me the answer. So the very famous rule which was given by the Gibbs, okay, the Gibbs phase rule says the police force having only 2 constables in that force, isn't it? So F plus P is equal to C plus 2. So police force with the 2 constables, isn't it? And when there is 1 constable, when we are getting it is condensed, so that we are assuming that all the reactions which are happening at the atmospheric pressure. So again we are reducing 1 variable, isn't it? Then it becomes P plus F or F plus P is equal to C plus 1. That is known as the condensed phase rule. This is known as the generalized phase rule. I hope it is clear. Very nice. When it is 1, it is condensed. We are assuming that the pressure is constant. We are reducing that variable. Only temperature we are keeping. Very good, Adnan. Very good, dear. Fine. Take the next question. So तारीख याद है किसी को? कल बोला था मैंने. Sri once again HSS tool. So it is 1841. What is there? What is there, Saraswati? Tell me, dear. Tell me what is there? 1841. What is there? It is tungsten, chromium, and vanadium. Tungsten, chromium, and vanadium. Tell me the answer. Oh my God! Very nice. Very nice. Very good. Very good. A. Very good. Tungsten, chromium, vanadium. Very nice, dear. बहुत बहुत बढ़िया. बहुत बढ़िया. Very good, dear. So it is a very common question. Yesterday we had discussion about this. Can anybody tell me what is the hot hardness temperature for the HSS? What is the hot hardness temperature? Yesterday we have discussed it in detail about these hot hardness temperatures. Can anybody remember? What is the hot hardness temperature for this tool? High speed steels. So dear student Bhupesh, see this phase rule actually. So for any particular alloy system, maybe it is a unary, binary, okay, tertiary, whatever the number of components you are having, okay, and with the phases you can able to see the degree of freedom, okay. So which thing we can vary so that which thing you can get. Say for example there is a pressure, temperature, okay, so there may be the composition versus temperature, so that anyone if you can fix you can able to get the different thing. So this is about this phase rule. So 650 is very correct, very correct, very correct, very good, very good. Take the next question. Which among the following has the poorest weldability? So dear student, as far as poorest weldability is concerned, whenever the percentage of increase or carbon content is go on increasing into the steel, it will be very difficult to weld. Okay. So tell me what is the answer. So actually see, poorest weldability, it is for the high carbon steel, and when you go for the very good weldability in case of this question, it will be the low carbon steel. Yes, C is the correct. C is the correct. Very nice, very nice. Good evening, Nehal, Shubham, Anurag, very good, dear. C, that is correct, that is correct. So this is a part we are running with the material science little bit. Of course, we are trying to cover the many sections, that is material science, metal forming, metrology, then casting. So today we try to cover all these things. Yes, high carbon steel. Come on, join this session. And yes, high carbon steel is correct. Take me next. The material to be rolled or beaten into thin sheets, dear student. Okay, tell me which is the property. The material can be rolled into the sheets. Yes, dear, tell me the answer. See the raw time, this is the purest form of iron, Bhupesh. This is the purest form of iron. Yes, malleability. Delhi, no more, Adnan. See, the ability of the material to get rolled into sheet, that will be the malleability, and can be drawn into the wire. It can be called as the ductility. Okay, so please remember. So yes, malleability is correct answer. Correct answer. B Bombay, very nice. B Bombay is the correct answer. Very good, Anjali. Yes, malleability is correct. Next question. The hyper-eutectoid steels have carbon content. Hyper-eutectoid. So if I draw the region which is showing the eutectoid region here only, I will try to draw here eutectoid region. Okay, of course there is a still more diagram is there, but here I try to draw this eutectoid. So this is my 0.83% carbon. Okay, so of course the below that it is the hypo eutectoid, and beyond that up to 2.1%, rather I'll say it is hyper eutectoid. Okay, 0.83, that is at 0.83, 100% perlite only, 100% perlite, layer by layer structure of ferrite cementite. ये कीड़े दिख रहे सब. Krishnamurthy is very correct. I hope. Shall we go for the next question? So see, if you want to see the diagram, see this is actually the eutectoid region. Here I have shown eutectoid region, right? So shall we go for the next? So take this question from PDIL 2009. The Martensite is a supersaturated solution of carbon in iron, steel, alpha iron and beta iron. Tell me the answer. I need answer. Nitish Kumar, tell me the answer. It is a supersaturated solution of. See dear students, so whenever you are quenching the austenite, okay, the gamma austenite rapidly within no time, okay, rapid quenching is done, definitely the gamma austenite is no more below 723 degrees centigrade. So below 723 degrees centigrade, the gamma ion has to be converted into something that is nothing but the alpha prime, which is nothing but the Martensite, isn't it? So Martensite actually, dear students, is a supersaturated solution of iron, not the alpha iron. It is a supersaturated solution of iron, okay, which is converting into this Martensite. Please remember, dear. Okay, so this has to be converted into something, so that is not the alpha, but it is rather than alpha, it is alpha prime, which is nothing but the Martensite. So A is the correct answer, dear all. Okay, please remember this thing. It is a supersaturated solution of. It is iron. It is supersaturated solution of iron. Okay, please remember this. Thank you so much. Take the next question. Yes, ball bearing. Bearing आ गया भाई. Bearing. So ball bearing are made up of very common question. Okay, please remember ball bearing. So of course they should be hard and wear resisting. So which is the element which can be added into the steel to make it hard as well as very good wear resistant? Yes. Yes, D for Delhi. Yes, chrome steel, dear students. What is steel? Carbon chrome steel. So chromium having very good wear resistance and also very good hardness, it will go along with the steel. Okay, Nehal, Saraswati, Shubham, very good, dear. Yes, come on, join this session. Today definitely we are trying to cover maximum questions. Okay, maximum questions today we are going to cover it. So be fast. This is a fast track revision. Tell me the following structure is obtained by Oss tempering process of the heat treatment. Oss tempering. Okay, generally this Oss tempering is giving us the Bainite. So it is again the Bainite at around 350 to 420 degrees centigrade upper temperature Bainite, and 200 to 220 250 degrees centigrade lower temperature Bainite. Yes, dear, very good. Bainitic structure. Bainite. So generally see the Bainite is nowhere getting produced, okay, as a industrial steel Bainite. but only the steel plant, Bosco's steel plant in the Korea, which is producing this Bainite steel for the industrial use. Okay. So see Bainite structure. Bainite is the correct answer. Bainite. Very good. Os tempering use Bainite. So Babbitts, again take the next question, Babbitts. So the bearings which are made up of the Babbitts, that is are the white metals, or the porous bearings which are made by the powder metallurgy, which are the self lubricated bearings, isn't it? Babbitts, porous, they are porous, because of that they are self lubricating. Okay, Babbitts. So B for Bombay. Yes, very nice, Babbitts. So porous bearings are made which are self lubricated, so no any additional need of the lubrication for these bearings. Okay, Krishnamurti, it is not A dear, it is B. Yes, lead based and antimony. Tin, antimony, copper, chromium. Okay, so with that we are making these Babbitts or the white metals. Next, which of the following is the case hardening process? Case hardening, dear. So see, spheroidising again it's a heat treatment, tempering is a heat treatment, normalizing a heat treatment, cyaniding also heat treatment, but which kind of heat treatment it is? Lead, tin, antimony, copper. Okay, we can having the Babbitts. Yes, which is the correct? Which of the following is a case hardening? Okay, we don't want the entire hardness throughout the core of the material. Okay, starting from the surface up to the core, we don't want. We are interested only in up to certain mm thickness from the surface. We want to harden the component. Okay, so that is known as the case hardening. Not the entire depth, but up to required depth of the, as per the requirements, we want the hardness or the surface getting heat treated. Very good. So cyaniding, very good. Cyaniding is correct. Very good, dear students. Take the next question. Take the next question, dear. Come on, very fast. So addition of magnesium to the cast iron increases its okay, Arvind Singh, love Dubai. Very good, Arvind. You go for D Dubai, we will go for D Delhi, IIT Delhi. Yes, very good. Come on, give me the answer. Don't stop, dear. So it should be live only. The chat box continuously should get moved. Okay, continuous movement should be there. Yes, C, it is not, dear, not C. Again C, B Bombay, very nice, dear students. See, whenever magnesium is added to the cast iron, it is going to improve its ductility. Please remember, ductility. Very good. Come on, Hari Praneeth, not the D, dear. Ductility, yes. B Bombay, that is correct. B Bombay. Okay, take the next question. So maximum surface hardness is achieved by. Okay, Avilash. So I am with India. Yes, the maximum surface hardness is achieved by. So out of this nitriding, cyaniding and carburizing. Okay, so सबसे ज्यादा मैक्सिमम सरफेस हार्डनेस जो होता है वी आर गेटिंग इट इनटू द नाइट्राइडिंग डियर. ओके, प्लीज रिमेंबर बी अगेन, बी फॉर बॉम्बे. Nitriding, maximum surface hardness where you get in this case hardening processes. It is in the nitriding. It is in the nitriding, dear. So B is the correct answer. No carburizing. Carburizing, it is less. Okay. So B is the correct. Please. So flame hardening for such a components which are very huge. Say for example, if I take the lathe bed and I want to harden that lathe bed. So are you going to take the lathe bed into hand and harden or movement for this heat treatment? Okay, so it should be you should go there and make hard that bed of the lathe. Okay, Sandeep. So dear, nitriding is there. Okay, flame hardening, there are the large gears are there. Then जैसे कि मैंने बोला कि so beds of the machine tools. Okay, and for that it is not required that much hardness with which the nitriding is going to give you. Okay, so don't worry. So B is the correct. Very good. Tempering is the process of annealing of. So tempering is what? The process of annealing. Yes, सबसे ज्यादा nitriding, then cyaniding, then carburizing. Yes. So it is given by the Rishabh only, Adnan. So take the next question. See, tempering is a process of annealing. So if you see again the FeP3C, okay, so here it is gamma austenite which is rapidly cooled to get the martensite, okay, which is very hard and brittle phase. So it is actually the useless for the as far as the engineering application is concerned. Martensite is no more with the use because very hard and brittle. So to improve their, say, to improve some ductility, getting the softness into that, right, we are heating this martensite. That is the secondary heating of martensite, which is cooled by rapid cooling of the gamma austenite below this lower critical temperature. Okay, below 723, that is we will getting the truesite, sorbite, bainite. Okay, so these are a kind of low temperature, medium temperature and high temperature tempering. Generally the tempering which is we are doing just below the lower critical temperature. That is the reason why, which is the martensite. This is nothing but a kind of, say, making the softness into the martensite. Okay, it is subject to take to some applications. Okay, engineering application. For that reason we have to improvise the some property of the martensite at low temperature, not at higher temperature. Okay, below lower critical temperature. So all these are low temperature, medium temperature and high temperature tempering processes. Okay, so tempering is done just below the lower critical line. So A is the correct. A is correct. A is correct. Very good. Yes or no? Martensite, annealing of the martensite at low temperature. That is correct. Below lower critical temperature. Which of the following material cannot be heat treated? Tell me which of the material cannot be the heat treated? Yes, come on, answer it, dear students. Yes, Sandeep, very good. Yes, very good. High carbon steels, very good, dear students, very good, Anurag. So please remember that the high carbon steel. So there are very ways to actually prevent these retained austenite. Okay, so there are many ways, there are many things we can have there into the retained austenite. Okay, so you are correct. Some austenite is always getting retained there. Whenever there is a formation of martensite, you are cooling very rapidly the austenite below 723 degrees centigrade. Okay, no, yes, high carbon steels. Okay, yes, so high carbon steel is a very correct. So see, heat treatment is basically done for the, actually see what we are getting by the heat treatment, we are improvising some properties, isn't it? So say the strength, hardness, ductility, whatever. So generally, so which are the low, see very ideal materials are the low carbon steel, and which the materials which cannot be heat treated can be get alloyed. Okay. So see, already there is a huge carbon percentage there in the high carbon steel, more than say you can say above say 0.8 to 1.5 up to 1.2 to 1.5 percentage of carbon, right? So because of this, Rishabh, low carbon steels are very good, and then the medium carbon steel, but the high carbon steels we cannot heat treat it. Okay, so please check it once again what you have read. Next, the structure of the austenite, the structure of the gamma austenite. Austenite, tell me the structure of the austenite. The steel is showing the allotropic form, isn't it? The steel is showing the allotropic form. So say at room temperature, alpha iron, which is the body centered cubic. Then the gamma austenite, the gamma iron, it is a face centered cubic. And again at the high temperature, delta iron is again showing you the BCC structure. Okay, so this is known as the allotropic form of the steel, isn't it? Yes, Meet, very good evening, dear. I know you. Yes, Meet Shah, very good evening. So what is correct here? FCC, face centered cubic, is correct. Okay, FCC is correct. Take the next. This machine tool guideway is already discussed by the flame hardening. Okay, by the flame hardening already I discussed. So next question. Take the addition of vanadium to the steel results in the improvement of vanadium. Whenever the vanadium is added to the tool steels, vanadium, it increases the keenness of the cutting edge. Keenness of the cutting edge. That is the main function of vanadium there. Otherwise in the steel it increases what? Vanadium increases for the steel. What it will improve? Come on, it will improve the hardenability. It improve the hardenability. The ease with which the material of steel get hardened. Okay. So B is the correct. B is the correct. Avilash, very good. Nehal, it is not fatigue strength here. It is a hardness, hardenability. Gamma is the gamma austenite here. Gamma austenite. Gamma iron or gamma austenite. Okay, from 910 to say 1400. That is a gamma austenite. Okay. Say, take the next question. Perlite is a combination of. So perlite. Okay, perlite, that is a pearl like luster. Okay, luster like appearance. And light matlab layer by layer form, layer by layer. So you can see perlite, it is a layer by layer structure. Okay, that results at 0.8 percentage of carbon. Okay, 100% perlite you can see there. That is a layer by layer structure of ferrite plus cementite. Ferrite plus cementite. Okay, so ferrite plus cementite, that is correct. So ferrite plus cementite, pearl like appearance, okay, moti ke jaise, right? And layer by light means small layer, it's a Greek word, pearlite. Yes, 87 point something plus 13, okay, so that means that was the percentage combination of that ferrite plus cementite. Yes, 87% and remaining 13% cementite. Very good, very good. Go for the next question. The main purpose of spheroidizing treatment is to improve spheroidizing. So dear students, spheroidizing, it is basically used for the medium and the high carbon steel to increase the machinability. Okay, so medium and high carbon steels. So medium plus high carbon steel. So whatever the carbides are there get converted into the globular form. Okay, globular form, so that machining can be very easy. Okay. Yes, dear Chahat Sharma, that is a level. That is very simple 1 mark question that we are getting into the gate examination, or very simple questions in the ESC also. This is the level. So yes, tell me, I already tell you the main purpose of spheroidizing to convert this carbon into the globular form, globule, so that the machinability can be very good. So it is high carbon steel or medium carbon steel, of course, to increase the machinability. So D Delhi is the correct answer. Dubai is the correct answer. Yes dear, come on, join the session. If the particular iron carbon alloy contains less than 0.83, it's a hopeless question now. It is what? Hyper or hypo? Definitely it is eutectoid, but which? You know it very well. 0.83 se niche, less than 0.83, it is hypo dear, and from 0.83 to 2.1 it is hyper eutectoid. Okay, that's very better. Hypo eutectoid. Okay, Dubai, very nice. It is hypo eutectoid still. Arvind, what you are writing dear? It is B, Bombay. Yes, very nice. Take the next. Now we started the forming. Forming started. Material science. Tata, bye, goodbye. Material science. Come to the forming. Very good. Take the question. Which of the following is an advantage of forging? So dear students, in forging, definitely what you are going to get. See, the main property of the forming process is what? Less losses are there, and very important advantage or very good property for these metal forming products are the material grain size can be get converted. Okay. Yes, that's correct. So material properties can be changed here. Yes, that's correct. And it is very particularly, we talk about the forging, we can develop or improvise the physical properties. That's better. Very good. Come on dear, improve the physical property. That is the correct answer. Krish Anand, Srinivas, Anjali Kumari, very good. So D Delhi, D Dubai. D for Dil, very nice. Anurag, Dil ka मामला है Dilbar, improved physical property, very good. Shubham, very good. D is correct here. Take the next question. The bolt head. I will draw the diagram. Tell me which process it is. Okay, tell me which process it is. Tell me. One is a moving pattern and other one is a fixed pattern. Fixed, and this is the moving pattern, and this is your workpiece. Okay, tell me which kind of it is. Forging operation. Yes, tell me whether it is swagging, roll forging, tumbling, upset forging. So dear students, it is upsetting. D again, very good. Delhi छा गया भाई, Dubai छा गया. D is correct. Bolt heads are manufactured by. It is the upset forging process is basically used. Not only upset forging, there are so many other things. But the basic we start with this upset forging. Okay, last we can do the chamfering. That is again we are requiring here blocking operation, finishing operation. Chamfering is there for the head. Okay. Yes, very good. D correct. D correct. Any other? What you are writing, King Maniac? Okay, this is not way here. Okay. Very good. Take the next. Take the next. Cold shed or lap may occur in the products obtained by. Cold shed. Cold shed. It is kind of overlapping or folding during the process. See, they are writing in the bracket lap. Okay, so don't neglect that word. That is very, very important. Upadhyay. Once again, revisit the question. Revisit the question. So they are saying cold shut in bracket lap. In bracket lap. So lap is kind of the folding at the end of the forged product. Okay, or in that folding some cracks are getting generated. Okay, at the corners in the forging operation. So only cold shut, that is the cavity which is produced due to the improper fusion of the two molten metal streams where they are meeting each other. Okay, so that is the cold shut. Of course, it is case of in the welding. Okay, when the two streams are unable to fuse properly, generating some cavity, that is a cold shut. But here in the lab, they are saying it is a lap. So it is a folded kind thing. Okay, and having the cracks in that, it is generally related to the forging operation. That's okay. That's okay. B is the correct. So no doubt it is a defect in the casting also, but they have written here the lap. So please remember, it is a kind of folding produced. So like folds are get produced, okay, at the corners of the forged product, and inside that we are having some cracks getting generated. I hope it is clear. So casting is there if only cold shut, if they mention there, but the lap is there, definitely forging is the defect. Cold shut is not there na for welding. Okay, so any such a defect you can have, particularly talk about the welding. Okay, so it is forging. Okay, so don't worry, it is not a casting, but lap is there, so definitely it is forging. Okay, take next. Yes, Nehal, Hashim, who is cheater? Okay, the process of coining is to make the coins. Okay, to make the coins, to make the medals. Which process? Which process is there? Tell me the process of coining. The coins are made, or the medals. Medals are made by which process? Which process? Of course, it is a forging process, dear. But whether it is a hot or cold forging? Yes, it is a cold forging process, dear. It is a cold forging process. That's better. Very good, dear. Very nice. This is the cold forging process. Very good. Very good, Hashim. Very good. Cold forging is the correct answer for that. Then tell me which of the following manufacturing process produce strongest component. So of course, without any hesitation, we can say the material properties will get improved, enhanced. We can reorientate the grain structure, that possible only with the forming operation, and forging is one of that. So definitely it is the forging. Okay, strongest components that can be made only with the forging. I hope without any hesitation we can say it is forging. Very good, dear Hashim. Very nice. Yes, forging. Come on. Take the next. Collapsible tube paste tubes are made or manufactured by which kind of? Anurag. There is no any rolling operation given here. Yes, tell me, collapsible tubes, the turmeric or cosmetic tubes or the toothpaste are made up of? Tell me, these are made up of which process? Of course, the impact extrusion is there. Okay, so seamless or collapsible tubes are made by using the impact extrusion. Isn't it? Take the next question. What does hydrostatic pressure in extrusion process improve? So hydrostatic extrusion is basically used for what? The materials which are brittle, semi-brittle materials, where brittleness is increase with the increase in the temperature. Okay, so that is the reason why we need the hydrostatic extrusion process, where we can able to minimize the brittleness of that material so that we can easily extrude them very nicely without the crack, without the failure. Okay, and that is the reason why we are improving the ductility in that. Okay, so yes, what does the hydrostatic pressure in the extrusion process improve? It is not improving the brittleness, it is improving the ductility so that it can be extruded without any crack. So I hope it is clear. Take the next question. Take the next. Which metal forming process is used for manufacturing of the long steel wires? Already discussed wires. Wires bole to it is deep drawing operation, not deep drawing. It is a deep drawing. We are making the cups in the forging operations. The forging products like coins, then connecting rods like that, crane hooks we are making in drawing operation. We are making not deep drawing, Shubham. In deep drawing we are making the steel cups. We are making the cups in deep drawing. In drawing operation we are making the wires. So drawing, it is a drawing. Wire drawing is there to make the wires. Tube drawing is there to get sizing of the tube, which is produced by some other process. Isn't it? Very good. So drawing is the correct answer. Drawing. Then the trepanning tool is used on trepanning tool. Trepanning. Wow, what is trepanning? Tell me what is trepanning. So trepanning is basically the drilling operation or making the hole beyond, say, the standard drill size. Okay, the standard drill size, if you see, up to 50 mm drills are available with us on the shop floor. So beyond that, you want to make any kind of drill, so there is a trepanning tool we are using like this. This is a trepanning tool we are having. Okay, and it is rotating, so it can produce the hole on a given plate like this. So overall we can able to produce such a kind of hollow portion. So yes dear, on the lathe we can use this trepanning tool. Okay, on the lathe machine we can able to use this trepanning tool. Okay, on the lathe machine. Very good Sandeep, Nitish, Tejas, Akriti. Okay, very nice. Tejas, very good. So on the lathe, next question. So generally the value of the point angle on the drill. Yes, large holes without drilling. Nitish Kumar, very good. That is the trepanning. So tell me what is the general angle, that point angle. This is the point angle dear. If this is the drill cutting edges, so this is the point angle. That is 2 beta. This is the point angle. Tell me how much. Very good dear. 118 degree. For the hard materials it is maximum. Yes, it is 118 degree for the very hard materials. For the soft materials we can go up to 45 to 60 degree also, very soft materials. But for hard materials generally it is 118 degree. Yes, very good, very good. Take the next question. Take the next question. The spline holes are machined by. The spline holes are machined by. See, very nice answer. We know it well. The broaching. Okay, the broaching is basically with the broach we can able to produce these spline holes. Isn't it? Chandan, Nitish, very good. Sumit, very good. Prem, Sandeep, Tejas, Giraj, D Delhi, that is correct. D Delhi, that is correct. Very good, very good. Broaching operation. Take the next question. Take the next question. Size of shaper is specified by. The size of shaper is specified by. Adnan, tell me the correct answer. Adnan, the size of the shaper is specified by. What is the answer? Very good Shivam, very good Nitish. So size of the shaper is specified by its length of stroke. Length of stroke, very good. Not the size of table dear. Not with the size of table. By the length of stroke the shaper is get specified. With the length of stroke. Yes, B Bombay is correct answer. Very nice, very nice. Take the next question. The different speeds on the lathe are provided. The different speeds on the lathe are provided in which progression? Whether it is arithmetic, geometric, harmonic or none of the above. So tell me how we are finding these. The different speeds on the lathe. Yes, very good dear. GP. Geometric progression. Yes, very good. Very nice. Excellent Akash, excellent. Geometric progression. Okay. Very good. GP. Very nice. So GP, geometric progression is correct. Take the next. Blanking and piercing operation can be performed simultaneously in. B for Bihar, Jindabad. Rakesh ji, tell me blanking and piercing operation can be performed simultaneously in. Simple die, complex die, compound die and combination of several processes. So simple die at a time only one operation. Okay. Complex die is not into the existence. Combination die, there are the different types of operations like cutting and forming. Okay. So here blanking and piercing are only the cutting operation, no forming operation. So of course the compound die, C for Calcutta now. C for Calcutta. Yes, Mohammad Adnan, very nice dear. Compound die, Giriraj Singh. Giriraj Singh, very nice dear. Chandan, very nice. It is the compound die, very good. Take the next question. A sheet of metal is being cut along its length in its straight line. Oh, that's very good. This is sheet cut along a straight line. Okay, so this operation is known as, tell me whether it is a parting, lancing, crimping and slitting. Okay, tell me the answer. So along the straight line, along its length, dear students. So parting up, it is simply breaking into the two. Lancing, that is incomplete hole at the mid portion, okay, and folding it, that is the lancing. So this is actually dear slitting. Slitting is this operation. A sheet metal is being cut along its length in a straight line. Okay, it is a slitting. So no one is correct. I think Raj Kamal is correct only. See, it is slitting operation. It is option D. It is slitting. Arvind, it is D. It is correct. Avilash, it is not dear. It is D. It is D, Avilash. See, whenever you are cutting the sheet along the straight line and small strips you are making, okay, like this. So one complete sheet is getting converted into small strips. So that is the slitting operation. Lancing operation, that is you are cutting midway in the sheet and it is just make it as an unfold, okay. You are not cutting it but just cut and separate it out. Like fold you can producing. Okay. So that is the parting, that is the lancing, and parting of simply you are cutting into two. One over another you can just put that and hold it, crimping. So it is a cutting, actually they are asking, its slitting is that along the straight line. Take the next. Flange wrinkles is the defect found in. So the crimping with the tool one or another sheet. Lancing, that is incomplete hole in between the sheet and you just unfold it. You are not removing that. That is the lancing operation. That is the lancing. किसनी सारखं म्हणजे लान्सिंग का, तसं नाही बाबा. Next. Yes, the flange or the wrinkle. See, the wrinkles which are present on the component, that is on the deep drawing operation. On the cup we are, you can see these wrinkles, okay. Again on the vertical wall or on the flange, okay, these are the wrinkles or earrings. So this is of course very simple. It is related to the deep drawing. It is related to the deep drawing. Very good, very good. D is the correct option. D is the correct. Tejas, Jai Hind. Yes, deep drawing is correct here. Tell me the next. Tell me the next. Spring back factor of the sheet metal depends on. The spring back factor of the sheet metal depends on. Come on fast. So spring back, how to calculate spring back? It is given like 4 times Ri divided by Et into sigma y to the bracket to the power 3. Okay. Minus 3 times Ri divided by Et into sigma y plus 1. Isn't it? Like that. So it is, yes, depends on the radius of bend and the thickness. Yes. So not only bend radius, not only thickness, not surface area, but both. So bend radius is also there and thickness is also there. Okay, radius and thickness, that is the correct answer. Radius and thickness. Yes, very good. KM Engineering Academy. Bend radius is very good. Bend radius and thickness, very good. Bend radius and thickness, that is correct. Next question. In piercing and blanking operation, the clearance provided between the punch and die depends upon. How to write the clearance? Optimum clearance. Optimum clearance. It is given as 0.0032 times thickness under root of shear strength of the material. It is on the radial clearance. It is a radial clearance. This is optimum radial clearance we are giving by 0.0032 times T root tau. Now tell me the answer. This clearance is depends upon whether it is depend upon the diameter of the hole, thickness of the sheet, number of pieces to be produced, capacity and type of the press. So ultimately, looking to the relationship, you can very nicely answer, and it should be B for Bombay. Very nice, dear all, very nice. So it is depends upon the thickness. Very nice, very nice. Which of the following process used to improve fatigue resistance? Fatigue resistance. Okay, tell me fatigue resistance. How? By inducing the compressive stresses onto the material. Okay, like for the season bat, you take the bat and you are keep hitting with the ball. Okay, like that. For the material also there is a cold pinning process, isn't it? Cold pinning. Cold pinning, very good dear students, very good. You know it very well. Cold pinning, so that we can induce the compressive stress on the stresses on the surface of the material, and the fatigue resistance can be improved, isn't it? Very good. Yes, yes, yes. You are malleting the bats, right? With the ball. That is spinning. Take the next. Gears in the mass production is produced by. The gears in the mass production is produced by. So one and only process, dear students, for that. This is very common, well known to you. That is the gear hobbing. So for the mass productions, we are definitely go with the hobbing process, right? So hobbing is correct. Hobbing, gear hobbing is correct. Very nice, very nice. All of you are correct. All of you are correct. You are intelligent peoples in my session. Very nice, dear. Very nice. Yes, that is correct. Raj Kamal, Mohammad, Adnan is there always. Ashutosh Rai, correct, dear. It is not shaping, it is hobbing, dear. Hobbing. See, hobbing is the correct answer. Hamid. Yes. Anurag, that is okay. That is correct, dear. Yes, Dhanipkar Sahib, correct. C. Take the next. Backup rolls are larger than the driving rolls because. Why we are need the backup rolls? Tell me. To increase the rigidity, to decrease the roll separating force, to increase the rigidity and decrease the roll separating force, and none of the above. Tell me. backup rolls. Say this is a small roll and this is the backup roll and this is our sheet is running. So why these backup rolls are there? To increase the separating, no dear, for decreasing the roll separating score we are decreasing the roller radius. Okay. So see, the force roll to separating force RSF is equal to simply saying that is sigma y into B LP, that is okay, into bracket 1 plus say mu LP by 4H average, that is the different story, but simply you can say roller radius means minimum, we are decreasing the roll separating force. But here I am talking about not the driving rollers, I am talking about the backup rollers. So to give the required rigidity, okay, or increase the rigidity of the process, the backup rolls are given, dear students. Please remember, not to decrease the roll separating force. A is correct, to increase the rigidity. These backup rolls are basically provided to increase the rigidity. Okay. So I hope it is clear. Clear. Next question. Powder metallurgy uses. Powder metallurgy uses. Powder metallurgy uses. Tell me the answer, dear. Yes, very nice, very nice. Raj Kamal, Hari Praneet, Tejas, very good, very good. Rakesh, Gautam. Yes, I am talking with Arvind. Mao, 2020. All are okay. Good evening. Pressure and heat. That is the correct answer. Pressure and heat. Yes, both pressure and heat. Yes, Prem, correct, dear. Yes, Tejas, very good, very good. Take the next question. So chills are used in the casting molds too. The chills are basically used achieve the directional solidification, reduce the possibility of blowholes, reduce the freezing time, increase the smoothness of the cast surface. Yes, to achieve the directional solidification or to achieve the progressive solidification. Not C, dear. To achieve the directional solidification, the chills are used. Very nice. So A is correct. Saurabh Gupta, it is correct. Yes. Anurag, that is correct. Take the next question. So directional solidification can be achieved by. So here the sole purpose of the directional solidification can be of course given by the chills. But here along with the chills there are two great soles are there, which is the chaplet and paddings. Okay, the chaplet, not only the main intention to provide the chaplet is support the core, and the main intention to provide the pads or paddings to avoid the sand inclusion. But along with these chaplets are also supporting for the directional solidification, and the paddings are also supporting for some critical section coolings. Okay, the coolings of the critical sections. So that is the reason why here they are saying that can be achieved by. So can be achieved by means not only the chaplet, not only the paddings, from the all, that is the chills, chaplets and paddings, isn't it? Yes, Anurag, chaplets are supporting the core, paddings are actually they are used to wherever there is a loose sand is there, say at the corner portions we are putting the pads, okay, but their main intention is different, but still they are supporting for the directional solidification. Okay, no Adnan, see along with the, see and what I'm saying, the sole purpose of chill is have the directional solidification, sole purpose of the chaplet to support the core, sole purpose of the pad to have the corners, again to remove the sand inclusion into the casting, that is the function of paddings. But again chaplets and paddings, again they are doing their additional functionality, that they are supporting the solidification, directional solidification. So D is the correct. Achieved by, can be achieved by both all of these chaplets, pads and the chills. Okay, Delhi Daredevils is the correct answer. Rakesh, very good. Take the next. Chaplets are used in the mold. Now see, tell me the answer. Now tell me the correct answer. Chaplet. The chaplets. Say this is my mold box and here is core is there. Okay. This is my mold, and to support this, okay, core into this mold cavity, I am using what? Yes, providing support to the core. That is the main or sole function of the chaplet. But addition to that, it is also supporting for DS. DS means directional solidification. Very good. D Dubai, very good. Arvind. Okay, Tejas. Take the next question. So casting defects which is not caused by the high pouring temperature of the melt. So see the cuts, the fusion of sand, the rat tails, these are the defects related to the, yes, high melting temperature, but the metal penetration is basically defect which is more pertaining to the welding operation. Okay, I hope it is clear to you. You know the casting and you know the welding, you can differentiate which defect from which side. See the cuts, fusions and the rat tails is basically the pouring temperature, high pouring temperature defects, because of the high pouring temperature defects. So penetration of the material or the molten material, that is definitely the defect related to the welding. Okay, so metal penetration should not be there. It is sand fusion, rat tails. Okay, molten metal can go and produces the rat tail like projections. So only the metal penetration is related to somewhat welding. So B is the correct. B is the correct. Next question. In solidification of the metal during the casting, compensation for the solid contraction. Of course, for the liquid contraction, there is a riser provision. We are providing the risers. But for the solid contraction here, there is a provision that we can have the plus or minus size of the pattern. Okay, the pattern size you can make plus or minus. That will be the size of casting size plus allowances, plus or minus allowances. So tell me what is the answer? What is the answer obtained by promoting directional solidification? No. Yes, provided by the oversized pattern. A is correct. A is correct. A is correct. A is correct. I hope it is clear, dear all. I hope it is clear. Are you getting the questions? Are you getting the practice? The main intention is that to practice here the most important questions for NLC. I hope it is achieved here. Yes, go to the America. Very nice, Arvind. Avilash, very good dear. Take the next question. In which of the following the metal molds are used? Metal mold which is made up of metal, that is a permanent mold. Mold which is made up of same low alloy steel, medium carbon steel. Okay, so tell me, only there is a one process here, only there is a one process, we know that, where the permanent molds are used. Yes, C, very good. Yes नीतीश, मेरे को भी. So tell me, die casting is correct. Die casting. Yes, die casting is correct. Very nice. Misran is a casting defect which occur due to. So generally we are pouring the molten metal with the pouring temperature which is 150 to 200 degrees centigrade. Then the melting point of the material to be get casted, and that is giving us very good degree of superheat. This 150 to 200 degrees centigrade, this is nothing but the degree of superheat we are giving, so that very nicely we can have the fluidity of the molten metal. It can reach without any resistance, very nicely it will go to the each and every corner into the mold cavity. So that is the reason why we are providing this degree of superheat, and it will provide the fluidity, excellent fluidity for this molten metal. So yes, and the misran is the defect which is occurred due to the insufficient, some part of the mold cavity left unfilled by the molten metal. Okay, so this is because of the insufficient degree of superheat or insufficient fluidity of the molten material. So B, Buckingham Palace, very nice. Very good, Adnan. Very good. So all the backups are ready, Tejas. Go with this defect. The scab is a. So we know we are having the Buckingham pi theorem in the dimensional analysis, Adnan. Again in the pressure vessel designing there is again Buckingham is there. So sad, Arvind. So tell me, scab. So whenever there is an uneven layer or some extruder, this something like this, non-uniform, some layers, some extrusions like things we are seeing onto the surface of the casting. Okay, of course this is a defect related to the sand casting. Okay, yes, very good dear. Sand casting, scab is the defect related to casting. That is some uneven surface is protruded onto the surface of the casting, that is the scab. Okay, very good. Take the next. The casting defect caused by the erosion. Yes, when from the cope portion some sand falls down into the casting, into the mold, okay, from the cope side, and it can lead to the erosion of the sand. That is the drop is the defect. Drop is correct answer. So dear students, I will wind up the today's session here. I am going to wind up the today's session here. I hope we have talked about the material science, casting technology. Also we have discussed the questions on the metal forming. Okay, so it was a fast track revision, rapid fire, isn't it? Very good. Drop forging, it lead to the erosion of the sand. So falling of the sand from the core portion into the mold cavity, isn't it? So dear students, do like this session and follow this session, share this session among your friends. Like this session. Okay, thank you so much for joining. I hope one more session is there for the NLC GET 2020 from my side. So definitely it will be on 13th. I will try to cover it at that time. So we have discussed many questions regarding to these first three topics. Okay, don't worry, Adnan will take that. So along with the metrology, we will include this industrial engineering together. Okay. So thank you so much, dear students. Yes, there is a metrology along with industrial engineering. Metrology along with industrial engineering we are planning. So if you want, you can take. So see, some questions are welding also, and I have the questions on. See, these are the questions on metrology. If you want, you can take. These are also, see, this is also defect related to casting. See, drop, dirt, wash, these are all the defects related to casting only. Yes, so industrial, along with industrial, I am planning to have these questions of this metrology. If you want to take, you can solve it right now also. Yes, yes, Adnan. So I hope we will wind up this session today, and definitely in coming session we will try to cover the leftover things. Then tell me the answer. Tell me the answer, Arvind. An optical flat measures the flatness of the surface by using principle of interference. Okay. So don't worry, we are going to cover it. Okay. So tell me the answer for this. The optical flat. Yes, optical flat is uses the interference principle. Okay, interference. Optical flat, interference. Very good. Nice. Take the next question. Which of the one of the following is used the checking of flatness? Again, autocollimeter. Again, based on the interferometry, we are using the flatness of the and in the gauge blocks. So tell me flatness measuring in an optical flat measures the flatness of the surface by using the interference. Now here, which one of the following is used for checking of flatness in the gauge blocks? These are the optical flats, dear. Please remember. D. Yes, correct. Take the next. The M and E systems in the metrology are related to measurement of M and E system. Where it is related? This M and E system. M and E system related to what? Yes, dear students, tell me the answer. So dear, this M and E system basically used for the surface finish. In the metrology, in the surface finish, these two systems are related here, M and E. D is the correct answer. Yes, Kamath, D is the correct answer, dear. Yes. Not about thread, it is a surface finish. Next question. The difference between the higher limit and the lower limit of is known as. The difference between the higher limit and the lower limit. This is the allowable permissible deviation. Okay, because we cannot able to reproduce the exact size again and again. That is the reason why we are giving the allowable permissible range. That is the tolerance. Very good dear. That is the tolerance. Very good. B is the correct answer. B, Bombay is correct. Tolerance is correct. Raj Kamal is correct. Rahul, around the world. Welcome around the world. Around the world in Street Mountain. Yes, B is correct. Take the next question. For the size up to and including 500 mm, the tolerance unit I is determined from this formula is given. I is equal to 0.45 cube root of D plus 0.001 D. The D stands for so D we can take it as in the steps of square root of maximum diameter into minimum diameter. That is what the geometric mean we are getting. Geometric mean. Isn't it? Yes, geometric mean. Correct, correct. Come on. We are trying to cover metrology part also in the today's session, dear all. So B, around the world, the geometric mean of the diameter stays between which the particular basic size is lying. So C is the correct answer. Krishnanand. Yes, dear, B is the correct answer. B is the correct answer. Take the next. So this is very simple. You can have the IT8 belong to 25. That is the tolerance grade for IT8. That is 25 I. That is okay. Take the next question. Take the next question. Tolerance are specified. The tolerances are specified. The tolerances are specified as it is not possible to manufacture a size exactly. Yes, that is allowable permissible range is given for us, isn't it? Very nice. So B is the correct answer, dear. B is the correct answer. Right, Rohit, very good. Rahul, very good. Chetan, it is not C, dear. Okay, allowance is different story. Yes, Nitish. So same size we cannot able to reproduce. So that is the reason why allowable permissible variation is allowed to us. So one thing you made it in India, one from you brought from America. So definitely when you make the assembly, it going to be get correctly matched. Okay. So because of tolerance. Very nice, Adnan. So now the fluid mechanics also it is in your mind. Very good. Tell me, expressing the dimensions like this, what does it mean? Unilateral, bilateral, limiting dimension, or all of the above? So it is nothing but see 25.3 they are saying plus or minus 0.05. So of course it is bilateral. B buoyancy now. Adnan, B buoyancy is once again correct. Very good. Bilateral. Very good. Bilateral is there. For the two sides in plus or in minus. Take the next question. Oh, done. It is done, dear all. So the work is done. So I hope We have practiced quite more than enough question for the today's session, dear, including now material science, metal forming, metal casting, and little bit some of the questions from metrology also. Isn't it? Yes, very good, dear. So dear, just see here, we are having the Gradeup Super launching these 3 courses. Okay, the Gear Up is very suitable course for the students who want to revise the entire GATE syllabus. You can see the course details. Rank Up is very ideal for the students who want to boost their GATE score, want to improvise their score. And the Vision 2022 is a very special batch, dear students, especially the students in the 2nd and 3rd year. They can have this Vision 2022 for GATE and ESE 2022. Okay, see the course details are in front of you. These are the star faculties from the Gradeup, right? These are our achievers in top 100. See, for the pricing, you can go through this slide. Any query, any doubt, you can contact on the given number. Okay, so dear, thank you so much all for being there. And yes, in the coming session, we will be discussing the questions on industrial engineering. Okay, so I am winding up this today's session. So thank you so much for joining. Like this session, share this session, and dear students, do follow me on the Gradeup app. So there are also many free classes are running every day, right? Do follow me on the Gradeup app. So thank you so much, dear students. Bye bye, take care, good night.